So page 245, number 7, they gave us a function, 2x minus 1 all over x plus 3. And they're asking us to describe the transformations. So the key part of this problem is that we need to rewrite it. We're trying to transform a parent function of 1 over x. So I want to rewrite this in a format that's going to make it easier for me to see what the transformations are. So I want it to be 1 over, and then that x is going to be in here. I could potentially be adding or subtracting something from the x. If I could potentially have some stuff out front that would be multiplying by it. And then usually if we're adding or subtracting to an entire function, like that would be a vertical shift. Usually we put that at the end. So I'm trying to squeeze this function into this format. It's going to remain the same function. We're just going to put it in a different format. So the way that we'll do this is by dividing this thing. So we could use long division or synthetic division. I'm going to go synthetic division because it's faster. So -3 would go in the box because we're dividing by x plus 3. My coefficients are 2 and -1. So this is going to be a quick one. 2 times -3 is -6. And we get -7 for our remainder. So far, so good. So what that has given me is that this function is equal to, my quotient is 2 plus, and then my remainder goes over top of what? X plus 3, whatever my divisor was. X plus 3. So we've been practicing division, and if you've been formatting your answers as I've asked you to, you should be super familiar with this. And the reason I asked you to do your answers in this format is because of what we're doing right here. So I'm going to kind of rearrange this stuff a little bit. So this 2 is being added. I'm just going to go ahead and put it at the end. So plus 2 rather than at the beginning. I've got an x plus 3 in my denominator here, and that's a -7 in the top. I want it to be a 1 in the top, so it looks like 1 over x. So I'm just going to make it a 1 in the top, and then I'll just multiply by -7 out front. That would be the same thing as this. Once I get it into this format, then this should be relatively easy for us to see what kind of transformations we're doing. I count 4 transformations here. You guys seeing 4? We've got a reflection over the x-axis. We've got a vertical stretch by a factor of 7, shift to the left by 3, and shift up by 2. And then from here, you would just need to tabulate some points and some asymptotes and show your steps there. Does anybody have any questions about getting it into this format? Let me ask you guys to do something really quickly. So this is transformations of 1 over x. Could you write me another equation? Let's call it g of x. That would be a transformation not of 1 over x, but a transformation of x squared with the exact same transformations that we did in this problem. I'd like everybody to do this right now, please. Let's make sure that we understand what's going on here. Can you look at this equation right here and apply the exact same transformations, but start with a different parent function than we did for that one? Can you write me an equation that would be a parabola or x squared parent function transformed with a reflection over the x-axis, a vertical stretch by a factor of 7, a shift to the left by 3, and a shift up by 2? I'm seeing some confused looks. What I'm asking you to do is write me a new function. It's going to be g of x. It's going to have the same transformations that this function has, except we're starting from a different parent function. We're starting with x squared instead of starting with 1 over x. Can I get everybody to pick up their pencils, please, and do that if you haven't already? You got it? So same idea as all of this, except basically, instead of this x plus 3 being in the bottom of a fraction, where's it going to be? It's going to be inside of parentheses getting squared. So I'm now, instead of 1 over x, I've got x squared. X plus 3, there's my shift to the left by 3. I'm going to do a reflection over the x-axis, vertical stretch by 7, and up by 2. Do you guys see the relationship between these two equations? They are the exact same transformations. We just started with a different parent function. I think sometimes my students are comfortable with this when they see it like this, or if it's inside of a square root, because we practiced that a bunch. We didn't practice so much with the 1 over x parent function back in chapter 1. So that kind of feels a little strange to them. Maybe this helps, maybe not. Okay, what other questions do we have, folks? Yes, thank you. 37. 37. All right, what did they give us? Rational function. 1 over 2x squared minus x minus 3, bless you. And instructions are find intercepts, asymptotes, and describe all the behavior. And then analyze and draw a graph. So in order to find intercepts and asymptotes, it's easiest to look at your function in factored form. So I'm going to go ahead and factor my denominator here. Oh, there should be a 2 up here. Thank you. All right, good catch. 2x squared, that's got to be 2x and x, and then 3 is 1 times 3. I think I want the 3 here and the 1 here. This would be 3x, and this would be 2x. Yep, we can get a negative x if the 3 is negative and the 1 is positive. So however you need to factor, if you need to do the x in the box to get that factor, then go ahead and do that. But first step would be to factor it. So the way this would look on the test would be, I'd have a spot here where I'd say intercepts, and a spot here that would say asymptotes. Then I'd have a spot here that said end behavior. And I'd have a spot here that was like asymptote behavior or something like that. So on the test, I won't be asking you to do like domain and range. I don't think so. But that's good practice for us. And we can go over any of that stuff if you'd like, but let's at least make sure we got intercepts, asymptotes, and behavior and everything else. So where does this graph cross the x-axis? Where would we find that in a rational function? That would be in our numerator. Do I have any factors up here that I can set equal to 0 and solve? No, so there are no x-intercepts. This thing does not cross the x-axis anywhere. Okay, it doesn't even touch the x-axis. What about vertical asymptotes? Those come from factors in our denominator. So set those equal to 0 and solve. You're going to get x equals -1. And that'll be 3 divided by 2. So x equals +3 over 2. Make sure when you're writing asymptotes that you're giving me an equation, and it should be an equal sign. Don't cross through that equal sign. So we took care of our x-intercepts. We took care of our vertical asymptotes. Let's talk about y-intercepts. How do we find a y-intercept of any function ever? Put 0 in for x. In other words, f of 0 is the y-intercept of any function ever. If we put 0 in for all the x's, we'd have a 2 left on top and a -3 on the bottom, 2 over -3. So my only intercept is a y-intercept. It would be 0, -2/3. Now on the test, I'm not going to have a separate spot for x-intercepts and y-intercepts. I'll know whether it's an x-intercept or a y-intercept because you'll put a 0 in for x or y. Okay, Don't lose points on the test for not giving me intercepts as a point. Intercepts are points. So I want to see an X and a Y coordinate for an intercept. Same thing with asymptotes. I need to see an equation. Don't tell me a vertical asymptote at -1. That'll get you half your points. I need to see X equals -1. Same thing with the asymptotes. I'm not going to ask you for vertical and horizontal asymptotes. I'll just say, give me all the asymptotes. I'll know it's vertical or horizontal based on what kind of equation you give me. We've taken care of vertical asymptotes. Let's talk about end behavior asymptote. Original function, is it top heavy, bottom heavy, or balanced? Bottom heavy. So higher degree on the bottom gives us an automatic horizontal asymptote at 0. So y equals 0 would be one of my asymptotes also. And say again. And that's probably why there are no x-intercepts, kind of, although you are allowed to cross a horizontal asymptote. So it is possible that we could have a horizontal asymptote here and still have x-intercepts, but this one just doesn't happen to have those. All right, end behavior. The end behavior asymptote, whether it's a horizontal asymptote or an oblique asymptote or a quadratic asymptote, this end behavior asymptote is going to tell you what the graph is doing at the far ends of the graph. I don't need to see a picture of this graph. I know that at the far left and the far right of the graph, it's going to be getting ridiculously close to this line. Okay, so my end behavior is going to be on the left, it levels out to 0, and on the right, it levels out to 0. So we just have to remember how to write that. The limit as x goes to the left, the y values level out to 0. The limit as x goes to the right, the y values level out to 0. Yeah. If it's a horizontal asymptote, if your end behavior asymptote is a horizontal asymptote, remember it doesn't have to be, but if it's a horizontal asymptote, then yes, your end behavior will match whatever that horizontal asymptote is. Now, if it's an oblique asymptote, like the last example we did last class, do you guys remember that one? It had like a diagonal asymptote, and the graph kind of went like that, and I can't remember what it did in the middle. If it's got an oblique asymptote, then that means that your graph is going, your end behavior is going to be heading towards positive infinity or negative infinity. Same thing if you had a quadratic asymptote. So the only time it's going to be heading towards a specific number will be if it is a horizontal asymptote. All right, the asymptote behavior, I'd want to see a graph of this or sketch a graph of this before I could do that. I'm going to just make a quick sketch of it off to this side here. What do I know about this thing? I know I have a y-intercept about right there. I know I've got a vertical asymptote at -1 and also at 3/2 would be about right there. And I know that I have a horizontal asymptote at 0 and the graph's going to be following along that. This one's a little tricky because I'm not sure which way to go from my end behavior asymptote. So I would probably actually start at my y-intercept. And so I'm starting in the middle and I'm going to go left or right. Doesn't really matter. Left. All right, so I'm going to head to the left from here. So as I head to the left from here, I'm going to hit this asymptote, and either I got to veer upwards like this or I'm going to veer downwards like this. Which way do you think I'm going to go? It's got to go down because why? No x-intercept there for me to cross. So we're going down here. And this was a single, right? So we're going to be going opposite directions, doing the opposite dance. So it must be going up on this side. And then we can kind of use that same logic to decide, oh, it's going to be going down here, and this will be going up. All right, so now I have an idea what it looks like. I can do my asymptote behavior. So this one's at -1. This is at +3/2. So the limit as x approaches -1 from the left. What are my y values doing on the left of this asymptote here? They're going up, positive infinity. And then the limit as x approaches -1 from the right. So the same asymptote on the right-hand side, though we're going down, so negative infinity. You're going to do the same thing with the 3 halves here and here. Was there anything else about the analysis part of that you guys had questions on? What others can we talk about from the assignment, folks? Mm-hmm. Yeah, let's have a look at 47. X cubed minus x squared, that's a terrible x, plus 1 all over x plus 2. And they asked us to find the end behavior asymptotes. Yeah. And then we'll go ahead and graph it. I said you didn't need to sketch your graph, but we'll have a look just to make sure we understand what these end behavior asymptotes are actually doing. So in order to do this, we need to get it into a format where we've got, well, first of all, top heavy, bottom heavy balanced, top heavy. So we're not going to have a horizontal asymptote, right? If it's top heavy, you will not have a horizontal asymptote. We're going to have an end behavior asymptote that's going to be something different. I can already predict it's going to be a quadratic because we're third degree and our first degree. In order to do this, we need to set this up so we've got a quotient plus a remainder over our divisor. Our divisor is x plus 2, so I know that part already. So to figure out what the quotient and the remainder are, I just need to do some division here. And I'm actually not too concerned about the remainder. The quotient's what's going to give us our end behavior asymptote. So let's go ahead and divide this out. We could do long division or synthetic division. I am choosing synthetic. Did you all catch that we were missing an x term in there? So don't forget your 0 when you do your synthetic division. So I got that, and we know where those pieces go. That's 1x squared minus 3x plus 6. You forgot the 0? Okay, cool. Okay. Yeah. So there's a couple of things. It's easy to forget those. A couple of things that'll help you with that. Play the little what do I know before I start game when you're doing your division. If you got a second degree and you're dividing by a first degree, you know your answer should be a second degree polynomial. If you forgot the 0, yours came out a linear. So that can help you avoid that mistake too. And also just the frustration of making the same mistake 100 times, and eventually you're just like, okay, I'm gonna keep my eye out for that next time. That's half of the advantage that I have on you guys. You know that, right? I mean, I know a lot of math, but I also like have made all of the mistakes so many times that I look for them and mostly avoid them. All right, let's finish it up then. So the end behavior asymptote would be y equals x squared minus 3x plus 6. Did anybody graph this to see how it affected the graph? You don't have to, I'll show you. I think I've got it already punched into my calculator. I do. I had to mess around with the zoom a little bit to make it work, but the function itself is the blue part here. You can see our vertical asymptote that's happening at x equals -2. So I can kind of see that vertical asymptote. And then the function kind of from that asymptote kind of comes and then rises up here. And then the red is the end behavior asymptote. And you can see like the end behavior asymptote, the function follows it very, very closely towards the ends of the graph, towards the left and towards the right. In towards the center, not so much. Like that's where it deviates away from it, but towards the left and towards the right, it follows that. All right. What other questions do y'all have? Yes. Oh, for the asymptotes? Yeah. So we'll go back to 37. So I think your question was like how to determine whether you're going to be doing the, the same direction dance that looks like this, or whether you're going to do the opposite direction dance that looks like this. Yeah, so when I look at this, I can tell that this is a single, because if it were a multiplicity of 2, we would have like a square here, or a power of 4, or a power of 6, or something like that. So remember, the multiplicity corresponds to the power on that particular factor. So these are both singles. If I wanted to change this one around and make it into a double, then I could square it here. And then I would see that behavior change on that graph. Great question, thank you. What other questions y'all have? Right. Yes, thank you. 63. I'm glad you asked about this one. I think we should probably talk about maybe a couple of these ones at the end. 63. A rational function must have a vertical asymptote. So 63 and 64, these are kind of like picky vocabulary type questions. And I didn't give you all the information you need to answer these. So my hope was that when you got to these, that you're like, where am I going to go to get the information I need? So what's the key information here? I would say, what is a rational function? What is the formal specific definition of a rational function? And that was not in your notes. Where do you suppose we could look to find a formal specific definition of a rational function? The index in the book? Yeah, where would you look in the book? We could look in the back in the index. I would personally notice that this section is called Graphs of Rational Functions. I'd be like, you know what? This is the first time rational functions has appeared in this book. I bet it's right at the beginning of this section. That would be the first place that I would look. If this whole section's about rational functions, I would not be surprised if somewhere right at the beginning, they might give you a definition of rational function. There it is. There it is. So our definition of a rational function is, okay, f and g are going to be functions, they're going to be polynomial functions. So the important thing is we have to have a function that consists of a fraction, and it needs to be a polynomial on the top and on the bottom. Do we remember what a polynomial is? The formal definition for a polynomial? All right, so let's think about polynomials. Can polynomials have, hang on, what was the question again? True or false? Does it have to have vertical asymptotes? Does it have to have vertical asymptotes? If it were going to have vertical asymptotes, would they come from the f of x or the g of x in this definition? G of x. Vertical asymptotes come from zeros of that bottom polynomial. Now, is it possible to have a polynomial that does not have any real zeros? Is that possible? Yeah, we've dealt with polynomials with no real zeros. X squared plus 4 is a great one. Yeah. X squared plus 1, even better. X squared plus 1 is a great one. That would have 2 zeros at I and negative I, but neither of them are real. So it could be a polynomial that could have imaginary zeros, and those imaginary zeros would not show up as asymptotes. So knowing that, let's go back and reread this and decide whether the answer is true or false. A rational function must have a vertical asymptote. True or false? False. I'd say false. And my justification would be, if the polynomial in the denominator has only complex zeros, then it wouldn't have a vertical asymptote. While we're here, 6 is negative I just 1. Negative I squared is 1. Negative I squared is 1. Negative I is negative I.
Negative I is negative square root of negative 1.
Correct. Yep. That's the opposite of I. But negative I squared is 1. Hang on. I'm getting confused. I need to see this. I need to see it. Ask me that question again. Negative root negative 1. That would be negative I.
Negative only applies, the negative outside of the square root only applies after you use square root.
That's a good way to explain it, yeah. Kind of like an order of operations thing, right? The exponent comes first. Square root is an exponent. So we would do the square root of the negative 1 first, and then we're multiplying that by a negative 1 on the outside. It's a good way to explain it. I like that. There is a super fun thing. So you guys know what I is? Okay, do you know what I squared is? I squared is equal to what? Is equal, here, I'm going to stack on this one. So I is equal to, well, I is equal to I, and I squared is equal to what? Negative 1. So what's I cubed equal to? Wouldn't it be I times I squared? Which would be negative 1I, right? I to the third power is just I to the first times I to the second, isn't it? So that would be I times negative 1. All right, what's I to the fourth power?
4. 1.
Which of these could we use to build it? We could multiply this by itself, couldn't we? That's 1. And then what would I to the fifth be? It would be this times this, wouldn't it? And then it just repeats. So there's kind of 4 things, and it just kind of repeats over and over and over again. So if I asked you in a lot of pre-calc textbooks, they'll throw a question in there. They'll say, like, what is I to the 81st power? Well, I would think to myself, what's I to the 80th power? 80 is divisible by 4. So yeah, so yeah. All right, anyways, let's number 64, got a little off track there. 64 is also about rational functions. Based on that formal definition of a rational function, is this a rational function? Is that a polynomial in the numerator? Yep. Is that a polynomial in the denominator? No. So this is not a rational function, because the denominator is not a polynomial and cannot be written as a polynomial. All right, last chance for questions. So today we are going to review